Let us now see the solution to first order first degree ordinary differential equation in variable separable form. Okay, so how to write that equation? For example, if there is any equation dy by dx is equal to f of x comma y, where this f of x comma y can be written explicitly as product of two functions h of x into g of y. Okay, then substituting them in this equation, dy by dx is equal to h of x into g of y. That is, if you can write a function as product of two functions where the variables are separated, okay, and the resulting differential equation is in the form dy by dx is equal to h of x into g of y. Here you can rearrange the terms. Okay, you can write dy by g of y. This is equal to h of x into dx. Okay, now when you integrate, you get the solution as capital G of y is equal to capital H of x plus c. Okay, this is how you can solve problems using variable separable technique. Okay, this is called variable separable technique. That is, when the function in the first order first degree ordinary differential equation, if the function can be written as product of two functions which are separated by the variables. Okay, that is, h of x is a function in x, g of y is a function in y. That is, these two functions are separated by the respective variables. H is explicitly a function in terms of x, g is explicitly a function in terms of y. So if this function can be written as product of these two functions, you can separate the functions via the variables, integrate and get the answer. Okay, this is a very basic method, but this is a very useful method once you start applying the solution methodologies of differential equations to engineering problems. Okay, now let's see an illustration. Let's solve 2 or 3 questions so that we'll be very clear with this procedure. Now, illustration 1. Okay, I have a differential equation dy by dx is equal to e power x plus y. How do I solve this? Okay, I know e power a plus b is equal to e power a into e power b. Okay, now this is a function of x comma y. Now I need to split it in terms of two functions. So dy by dx is equal to e power x into e power y. Now I bring e power y to the other side, dx to the other side. Dy by e power y is equal to e power x dx. Now integrate it on both sides. What is that you get? Minus e power minus y is equal to e power x plus c. That is, if you try to rearrange, okay, you will get e power x plus e power minus y is equal to minus c, which you can take it as some k. Okay, this is the solution to the given differential equation. Alright, now let's take another question. illustration 2. What is this? Dy by dx is equal to some x square y. Okay, how do I solve this? This is a function of x and y, but you can write them as a product of two functions. So separate the variables here. Dy by y is equal to x square dx. Now integrate on both sides. This is ln y is equal to x cube by 3 plus c. Okay, this is nothing but y is equal to e power x cube by 3 plus c. Okay, so y is equal to e power c into e power x cube by 3. Okay, e power c is a constant. Therefore, y is equal to some k times e power x cube by 3. Right? This is the solution to the given differential equation. Okay, now let's see illustration 3. Illustration 3. You may be asked questions like a solution of dy by dx is equal to 9x by y represents. Okay, he may ask you based on the nature of the solution of this differential equation, what does the solution represent? Maybe a circle, or it can represent a hyperbola, it can represent a parabola, or it can represent an ellipse. So how do you answer such question? The only thing is you need to solve this. So the given equation is dy by dx is equal to 9x by y. Okay, so you separate the variables. What is that you get? Y times dy is equal to 9 into x into dx. Now integrate this on both sides. So you get y square by 2 is equal to 9x square by 2 plus c. Okay, some constant. Now bring this to the other side, or you can bring this here. What is that you get? 9x square by 2 minus y square by 2 is equal to some k. What does this represent? This is the solution, right, for the given differential equation. What does this represent geometrically? This represents a hyperbola. Okay, so option B. So he can ask you, based on the nature of the solution using variable separable technique, he can ask you what does the solution represent, any properties of the function you get as a solution for a given differential equation. So this is basically, it's a very basic technique, variable separable, but you will keep on using this in your engineering applications as and when differential equations creep in. Okay. Now, what if a differential equation is in the form dy by dx is equal to f of ax plus by plus c? Okay, here you cannot express this in terms of some h of x into g of y. You cannot express this function in terms of h of x and h of x into g of y. So what is that you do here? Using a substitution, you actually try to bring this to variable separable form. Okay, you reduce the given differential equation to variable separable form. This is very, very important. So what is the substitution that we do here? Substitution. Take ax plus by plus c as some v. Okay, now differentiate on both sides. You get, with respect to x, a plus b dy by dx plus 0 is equal to dv by dx. Okay, so b times dy by dx is equal to dv by dx minus a. Okay, so dy by dx is equal to 1 by b times dv by dx minus a. Okay, now let's substitute this here. What is that we get? Dy by dx as 1 by b times dv by dx minus a is equal to f of v. Okay, so now this is nothing but dv by dx minus a is equal to b times f of v. Now dv by dx is equal to b times f of v plus a. Correct? Now bring this to the left hand side. This is nothing but dv by d times f of v plus a is equal to dx. Now when you integrate on both sides, this is nothing but variable separable form. Now when you integrate on both sides, you get the solution. Okay, this is reducing the given differential equation to variable separable form using a suitable substitution. Alright, let's see an illustration where we can use this kind of substitution and reduce a given differential equation to variable separable form. Let's take an illustration. Dy by dx is equal to sine of x plus y. Okay, what is that you use here? Okay, you need to use a substitution. Where x plus y is equal to sum b, 1 plus dy by dx is equal to dv by dx. So dy by dx is equal to dv by dx minus 1. Okay, now you substitute this here. What is that you get? dv by dx minus 1 is equal to sine v. Okay, dv by dx is equal to 1 plus sine v. Right? Now, I am just continuing this here. Now, dv by 1 plus sine v is equal to dv by 1 plus sine v. This is equal to dx. Okay, now try integrating on both sides. Okay, what will you get? What is integral dv by 1 plus sine v? This is nothing but tan v minus secant v plus c is equal to some x. Okay, now what is v? V is equal to x plus y. So this is nothing but tan of x plus y minus secant of x plus y plus c is equal to x. Okay. You may ask me, how did you suddenly get integral dv by 1 plus sine v as tan v minus secant v plus c? This is your basic 12th class math. Okay. This is something when you remember, it's very handy in the exam. You keep dealing with this integral very often in GATE exam. Okay. So this is nothing but sine of x plus y minus 1 by cos of x plus y plus c is equal to x. So this is the solution for the given differential equation. So here the differential equation, if you see, this is nothing but function of x comma y. You cannot write this explicitly as some h of x into g of y. Okay, this is not possible here. So what is that you do? You substitute x plus y as some v and convert or reduce this particular differential equation to variable separable form. Then find the solution and substitute back v as x plus y in the solution that you get, so that you will arrive at the general solution of the given differential equation. So this is a very conceptual video on variable separable technique. Of course, for advanced applications, you will be using variable separable technique as and when applicable. As far as GATE and other entrance exams are concerned, I think this knowledge of variable separable technique is enough to solve questions in the examination. Okay, I hope you understood the methodology. I will be back with another conceptual video. Happy learning.